Okay, this is on stoichiometry, putting it all together. And so we've been working on the different parts for stoichiometry up to this point, and now we're going to put it all together. And these problems I'll be showing you will have the grams to grams. But please understand, throughout this whole unit, you're expected to be able to analyze a problem and figure out, are you going from grams to moles, moles to grams, grams to grams, grams to ions, atoms, or molecules? You have to discern what you're going to be needing in order to get from point A to point B. So, the first example I've already pre-set up for you. So here's my prompt. It says, what mass of oxygen will be needed to burn 36.1 grams of B2H6? Now, on these problems, the first thing you're going to have is a balance equation. So either A, I'm going to give you a problem with the equation already balanced for you and set up. B, I'm going to verbally give you the equation and you're expected to write the equation and balance it. Or C, I'll give you the equation and you're expected to balance. So, just like we done before, I gave you an amount, 36.1 grams. I'm starting with that, just like always. Again, railroad tracks, 36.1 grams B2H6 over 1. So we're starting the same we've done before. Then I go to my periodic table, I add up my parts of the B2H6, and I get that its mass is 27.68. That's 1 mole. Now this step is going to come from your periodic table. So if I go to look at B2H6, the coefficient out front of it is 1. So I'm going to put down here 1 mole B2H6. I want to know about the oxygen. And I go to my oxygen and there is 3 in front of it. So I'm going to put a 3 here for 3 moles O2. Now I'm being asked for mass, which means I need to have it in grams. So I have one more step to go where I'm going to take the moles that I have and convert it over to grams. So 1 mole of O2 goes on the bottom. Periodic table tells me that O2 is going to be equal to 32 grams, and that's what's going to go on top. I do the product of the top divided by the product of the bottom, and I'm going to get 125.2. So the next problem says, how much HbO2 is produced by 140 grams of B2H6? So again, we're going to start off, we're going to have our railroad tracks. Since I'm going from mass to mass, and I'm going to go mass, mass of moles, moles of moles, moles of grams, or mass. I start with what I'm given, which is the 140. And I'm going to label over 1. Now, my grams of B2H6, we've already done that once before. We know that it's 27.68 grams B2H6. And that is equivalent to 1 mole of B2H6. Now, I'm going to go back to my balance equation. I have a 1 in front of the B2H6. So this is going to be 1 mole B2H6. And I want to know about HbO2. There's a 2 in front of it. So I'm going to put 2 moles HbO2. Now, final step, I need to get it back to grams. So I'm going to put 1 mole HbO2. And on top, when I do the math for that, I get 43.82 grams HbO2. And so when I perform the operation, if I have 140 grams of B2H6, I'm going to produce 443.27 grams of HBO2. Let's look at one more example. So here I've given you an equation, C8H18 plus O2 yields carbon dioxide and H2O. So this is a combustion reaction because I'm producing CO2 and H2O. I have a hydrocarbon in the presence of oxygen. So the question asks, how many grams of oxygen needed to fully react 837.4 grams of CHH15? Now just looking at this, and I'm looking at my ratios, it's a 2 to 25 ratio. So this is probably going to be a pretty fairly large number. Okay, just looking at my ratios here. But let's go find out. So again, first step, boom. Here comes in my railroad tracks. I'm going to go from grams to moles, moles to mole, and then moles to grams. Okay, boom, got that. So here we go. Let's rock and roll on this. So I'm going to start with putting in the 837.4 grams C8H18 over 1. And when I go to my periodic table, 1 mole of C8H18 is going to weigh 114.23 grams CHH18. Now, I go back to my balance equation. There's a 2 in front. So I'm going to put 2 moles CH8H18. And I'm 1 over with the oxygen. That's 25 moles of O2. And the final step, I need to get it back to grams. So 1 mole of O2 weighs 32.0 grams O2. And when I do that math, product at the top divided by the product at the bottom, I get 2.33 grams O2. Okay, and that's how you do your stoichiometry with the full set.